you have questions like that on homework. Find a minimum sample size. So the difference between the one you have in the homework and that one is that you want to find a minimum sample size in your homework, and there you are already having a portion of it. You have some, and how many more will you need? Have you seen questions on sample size on homework? Has anyone done any question? Which? Okay. So it's just like if you are able to know the number of people you need, and you already have some, can you tell how many more you need? Has anyone done that homework problem related to minimum sample size? So that we do it together. Okay, let's look at that. Can we all look at this number 9? Was it about mean or proportion first? It was mean? Okay, this is one for proportion. Let's look at something about the mean. 7.1. Do you have number 15? It's homework. You have number 15 here. You got that one right? Okay, let's use it. Yeah, we are going to see the relation between the two. So you find the sample size necessary for an 80% confidence level with a margin of error of E equal to 0.08 for the mean weight of the, so you could find that. You could do this one, right? Correct. So what is the problem? Can you explain again? That's interesting to know what is the difference between what you can do and what you cannot. To do this one, did you use X bar? To do D, did you use X bar? If you think about the solution for D, everybody should think about it. You would have done the homework already. Do you need the mean to answer question D? No. Do you remember the formula to answer question D? N equals to Z alpha over 2 sigma over square root of E squared. So you need this, the standard deviation, and the maximum error of estimate. Yeah, because it was the previous study. Here you need a sample size. Without the sample size, you cannot even find S, right? So it is not the S for what you want to do. It's S that was done before. If something was done before, S becomes like sigma. Do we get this? S is like an estimate of sigma because it's not about the sample you are working on. It's for some previous. In this example, you are giving sigma in this case, but in yours, there was a first study and people were not comfortable with it or your take-home problem. And now you want to do another one. And then using the standard deviation of the previous one as sigma, find the minimum sample size. Knowing that you had already had a some number of values, you want to think what to do to get more values. How many more do you need? Do you get that now? Okay. When you read that, can you read the statement asking you for the minimum sample size? Mm-hmm. Hearing this, can somebody tell us what is the margin of error? Yes? Within 1. When you hear within, that is you don't want to exceed. So that's the maximum. Is that good? Thank you. Any other question? Mm-hmm. We want to look for a homework problem that looks like that. If you want us to do it, you meet me in the office or on Zoom. In class, we do homework, which will have just like what we have just done now. So we should look for homework. Can you tell what section it is from? 7.1, 7.2, 7. Can you just read it, then we will know. Mm-hmm.
So A is if you have no preliminary estimate for P, how many male athletes should you include in a random sample to be 95% sure that the point estimate P hat will be within a distance of 0.05 from P? And B is studies show that approximately 19% of male athletes wear contact lenses during performances. Answer part A using this estimate for P.
Anybody has an idea what problem is like this one? Homework problem that looks like this. Come on. We just look at number 9 here. Look at this problem. What is the minimal sample size needed for 95% confidence interval to have a maximal margin of error of 0.1? A, if a preliminary estimate for P is 0.25. B, if there is no preliminary estimate for P. Does it look like that one? If it doesn't, let's speak about how you see there is a difference. That is how we will be learning. Can you identify what is the confidence level in your problem? Remember that n is equal to what? E cubed z alpha over 2. So you need the confidence level to know z alpha over 2. The margin of error, you should be able to identify it. And then PQ. Do we get this? In a problem of minimum sample size for proportion, you need to know do you have P? What is A there? You have A and B. So it is the B here, right? So we say that if there is no P, what do we use for P? Pardon? We use P for half and Q for half, and it gives us 1/4. So yes. That Z alpha over 2 is always there. We need to know what it is for 90, 1.645, 95, 1.96, 99, 2.58. You have to do the homework to remember. If you want to just memorize those things, it will be very confusing. When you do 2, 3 problems, you will realize that you know what it is. But if you forget, the PowerPoint on Canvas has like at least 3 slides with Z alpha over 2 for several confidence levels. Are you getting it now? Do we get how to do the take-home problem if we can do this one? You don't want to just say yes. So I am pleased when I feel like you have learned something. Not because there is no question. Do we get this? So compare and feel about it. Feel like, oh, I see what I'm supposed to do. So whenever you have a problem for minimum sample size, if it is for mean, you need sigma. If it is for proportion, you need PQ. If you don't have P, use half, half. Multiply half by half, give 1/4. If you have P, that's the B part or the A part, depending on how I ask the question. You replace it by, here P is 0.25, that means 1/4. What should be Q? If P is 0.25, what should be Q? 0.75. Those are some of the things that might stop you from proceeding because you might not know what is Q. So when we are doing it and you don't know what it is, just ask. And understand that you are the voice of the voiceless. Because some people don't know also, but they don't want to ask. But if you ask and you know, you just move. That's how life is. Big problems start with little ones. You solve those little ones, at the end, you don't have big problems. Okay? Yes. How do you know that? Can you read a statement that have 0.05? Are we hearing that statement that tells us what the margin of error is? It might not be exactly like that, but what it wants to say is that your error should not exceed some numbers. That number that they give you is the maximum error allowed, which we call the margin of error. Is that right? Any other question? do you use the Z distribution or the T distribution? When do we use Z distribution? When sigma is none, we use Z. When sigma is unknown, we use T. For both, we require population is normal or sample size is at least 30 for both. Now, to make the difference between T and Z is the knowledge of sigma. It's like you like working more on the take-home problems than the homework. No problem about that, but that's my observation. Because it gives more points. I just want to know. It helped more to prepare for the exam. So, any other question? I like doing homework in class. Not that I want to do your homework, but I want you to ask me questions. Because there is more questions that you will come across from homework that will help you to understand the take-home problem. That was my intention, actually. You do the homework. When you are satisfied with it, you now do the take-home problem. Any other question? You can get your inspiration from take-home problem. There's no problem. But what we are going to look at is a homework that looks like that. Okay. If there is no more question. If you are on Zoom and you have a question, you can also let us know. So those on Zoom, when you are on Zoom, don't think it's because you are on Zoom, you are not part of the class. I assume you are part of the class. So you can ask questions. You just set your microphone and ask your question. So we are going back to chapter 8. That means we are done with chapter 7. In chapter 8, we are going to learn about what is called statistical test. In chapter 7, we learn about an aspect of inferential statistics will consist of making an estimate for a parameter using a statistic. We did it for the mean and for proportion. For the mean, we had two cases, when sigma is known and when sigma is unknown. If there is time in chapter 10, hopefully we are going to get to it. We are also going to learn about the variance and the standard deviation. Another type of inferential statistic is decision making or hypothesis testing. Here we are given an information about a parameter, and we want to decide whether that information is valid or not by testing using a sample. So we call it hypothesis testing. A statement about a parameter is made. I have a coin and I tell you, this is a fair coin. You want to check if I'm right. Is it really a fair coin? If it is a fair coin, then the proportion of heads should be equal to the proportion of tail. You will decide to toss this coin a number of times. That's your sample, maybe 50 times. And you get 28 heads or 22. And you want to determine, is it because I don't get exactly half that it is not fair? We are going to set rules by which we will decide if the answer you have from the sample is significant or not. Is the difference between getting 25 heads and what you have large enough for you to conclude that the coin is not fair? That is an example. So we are going essentially to make a decision, either to reject or not to reject the statement. There are two types of statement in statistics. The first one, which is called the null hypothesis, assumes the status quo. It assumes that things are just the way it is. For example, cold lead to flu. That is a statement everybody knows. We will take that as a null hypothesis. But practically, we are going to give conditions that will help us determine if a statement is a null hypothesis or not. If a statement involves an equality, all of this is on your PowerPoint. If I begin to write, I will change and go to, do you like when I'm writing? Or just, I want to do the introduction and then we will write the important part of it. If I make a statement that involves an equality, for example, the average age of St. Francis University student is at least 20. When I say at least 20, it means it's greater than or equal to 20. Do we know that? So there is equality in it. That is considered a null hypothesis. If I say the average age of St. Francis University is 20, that is equality, is null hypothesis. That's how statistician has agreed to identify the status quo. It has equality. The alternative hypothesis is the hypothesis that should be considered when the null hypothesis fails. If say there are more people who like wearing masks than those who don't, that is an alternative hypothesis because it is more. There is no equality in it. So alternative hypothesis is greater than, less than, or not equal to. So in general, you will be given a statement about a parameter, and you want to determine if that statement is null hypothesis or alternative hypothesis. So we denote the null hypothesis by H0, as you can see here. For example, here, we believe that the average height of professional male basketball player is taller than it was 10 years ago. We will use H1, mu is greater than 6.5, and H0, mu equals to 6.5. Even when it is greater than or equals to, less than or equals to, we always express the null hypothesis as equal. So this is another example. A car manufacturer advertises that its new subcompact models get 47 miles per gallon. Let mu be the mean of the mileage distribution for this car. State the null hypothesis. Null hypothesis is mu equals to 47. In this statement, what this guy is trying to say is that we can go to 47. We can get to 47 with our car. So we will say mu equals to 47. And we will be checking if this is right or not. So there are two types of tests. There are up to three, not two. There are three types of tests. The left, the right, and both, or two-tail. We say left tail, right tail, or two-tail test. So when we are doing, we will do a lot of examples so that we can understand what each of these mean. A test is considered left tail if the alternative hypothesis is about less than. So alternative hypothesis is what determines the test. If you want to write something about here, and you want to remember, the nature of the type of test is determined by the alternative. The type of test is determined by the alternative hypothesis, H1. So we have two types of tests. Left tail, white-tailed, and two-tailed. And two-tailed. I will use the example of the mean, but for any parameter, it's the same type of situation. So in our hypothesis, we say the parameter is equal to A for the null hypothesis, but for left tail, it's less than A. Mu equals to A. Mu is greater than A. Mu So I will use these graphs to illustrate the reason why we call it left or right. I will start with the left tail test. In this case, we are saying that the mean in the alternative hypothesis says that the mean is less than A. The null hypothesis says that the mean is A. If the alternative hypothesis says that the mean is less than A, then the null hypothesis actually says that it's greater than or equal to A. We write it always equal to because we want to start from that point. Yet, what we mean by mu is less than A is that the otherwise of the null hypothesis is it is less than A. So we will always assume that the null hypothesis is true. And in that case, if we are somewhere here, we look at where I'm showing. If we are somewhere here, are we consistent with the null hypothesis? If the null hypothesis tells us to understand the null hypothesis, look at the alternative. You will understand it better as we do more work as we go into the future. We are always going to be writing equal to, but what I want you to understand is that as we are writing equal to, it could mean greater than or equal to. So you know that it's greater than or equal to by the alternative, which is less than. We are here. Is it consistent with the null hypothesis? Please pay attention. If we are here, is it consistent with the null hypothesis? And if we are a little bit above, is it consistent? If we are somewhere here, is it consistent? Remember, null hypothesis is kind of the opposite of the alternative hypothesis. In the alternative hypothesis here is mu is less than A. So the null hypothesis is what? Mu is greater than or equal to. So in this question, the null hypothesis, the static code, what everybody knows is that the mean is at least, for example, the mean is at least A. If it is somewhere here, is it consistent? Is it at least A if we are here? Right? It is consistent, it's at least A. We are going to force and move, but you will understand why we always write equal to, but I want us to understand the meaning of that equal to. It's not really equal to. It is because we are going to use that number in the formula we are having. So if we are above A, we are consistent. Do we get this? If we say the average salary at this community or this county is 35,000. If we take a sample of 50 individuals and their average salary is 40,000, is it consistent? It is consistent, right? So now, if we are here, will it still be consistent? Please think, that will help us and help you in your future work in life? Is it still consistent if you are here? We will feel like it is not consistent. But our question is, it might still be consistent. But how far away from here are we going to get before we begin to doubt if the statement about the parameter is true or false? Are we getting what I'm saying here? So we are going to set a boundary here. And we are going to call it our critical point. And this area, we will call it the rejection region. Do we understand this? The rejection region. Somebody tells you, I make at least 50,000, I make at least $1,000 every month. You look at his paycheck first month, 800. Second month, 700. Third month, and you take the average, 800. Or you just get, by luck, you find 10 of his paycheck any time during the year. You take the average. If it makes 800, you might be feeling like, I don't think he's right. But it could be that you just took some few that are not the real one. So we will allow possibility of error to the left so much that we will put a boundary that, hey, from this place, no more. So like my coin, I tell you, is fair. You toss it 50 times and you get 10 heads. You will feel like this is too small. When is it too bad? That is where we put these boundaries. Same thing for right, but for equal to, we are going to put it on both sides. For example, we might say a healthy individual has a blood pressure of 120. You know what blood pressure is. But we may say that somebody might have a blood pressure of 60 and is not healthy. Somebody might have a blood pressure of 160 and it is not healthy. It could be on both sides and we might go wrong. That is what we call a two-tailed test. Then we are going to put two critical points. So as we move on, we are going to learn how to identify each of these critical points and how to determine if the test value that we have from the sample is going to go to that tail. Actually, we are going to call this one alpha over 2, this one alpha over 2, this one alpha, and this one alpha. When it is one tail, it's alpha. We call it the level of significance. So you might take your sample, and for some reason, it gets into this tail, and you are rejecting the null hypothesis when you were not supposed to. So I'm going to take this away and explain another thing, error in hypothesis testing. And make a mistake. In life, we can always make a mistake. I want to divide these errors into, I want to present it on a table. So we can assume that H0 is true. H0 is false. We can decide to reject H0. If we get into those tails, we reject H0 and do not reject H0. So think about it as it's normal for somebody to be healthy, right? It's normal to be healthy. Everybody is supposed to be healthy. What else do we say everybody is supposed to be? Anybody remember anything? In justice system, what do we say? Everybody is considered innocent, right? Innocent until proven guilty. You know that statement? We can use both, any of those two to illustrate what we are talking about. So when you go to the doctor, he cannot assume your disease before he checks. We will call it you are healthy, that you don't have the disease. If you go to court, you are considered innocent not innocent. You can receive treatment, or you can be convicted of the crime. Rejecting H0 is giving you treatment. Rejecting H0 is convict. That is the jury convict. Do we understand what I'm saying here? So you do not reject is no treatment. I want us to do section 1 and 2 today, not convict. But if you understand what we are doing here, it's going to help us as we move on. So we want to know which of these decisions is correct. If we are here, will it be a correct decision? If we are here, you are healthy and you are given treatment, is that correct? Is it okay if you go to the doctor, you are not sick, and he tells you to take a treatment? It's not good, right? He decides to operate on you when you don't have any problem. It's not good. But this is bad. We call it a type 1 error. Here is good, here is good, and here is type. You will see that some people commit type 1 error when some commits type 2 error. A doctor that commits type 1 error is the one that will prefer to give you treatment rather than sending you home by mistake. In that case, he will commit type 2 error by not giving, I'm sorry, if you are trying to avoid a type 1 error, you are the type of doctor that does not want to give treatment when the person is not really sick. It will be possible for you to commit a type 2 error. You are a jury and you don't want to convict an innocent person. Type 1 and type 2 error are like in a balance. So the probability of committing a type 1 error is called the level of significance of the test. Probability of type 1 error is alpha, which is level of significance of the test. On the PowerPoint, you are going to read that the probability of a type 2 error is denoted by beta. We don't need it in this class. And we will call the power of a test the probability of not committing a type 2. So sometimes people want to decide which one do you want, type 1 or type 2. That's like conservative and liberal. You can fight all your life and you will not know who is right. Okay, so let's go back to the PowerPoint. Knowing what a type 1 error is, the probability of rejecting a null hypothesis when it is true. That is a type 1 error. We want to use that type 1 error to determine the critical point. That is the point for which we will feel like, unless we are committing a type 1 error, this is acceptable. And that is what gives us those margin of errors. I mean, sorry, those rejecting regions. So I'm going to start with some examples. How do we determine, how do we conduct a test? First, we identify the claim. What is the claim? Now, using that claim, whether it has equality or not, determine whether it should be H0 or H1. Then we compute the test value using the hypothesized parameter. We are going to be using calculator to do this, but we are going to look at some examples how to do it manually. Compute either the p-value or the critical value, and then make a decision to reject or not to reject the null hypothesis. Draw a conclusion. Those are the steps. We've gone through this. I'm going to explain the notion of p-value and critical value using the whiteboard. It's something that, so what we are doing is this. We are going to compute value. Call it T. We are using the example of the mean. We set this guy here as A. But I want you to know that in order to perform this operation, we will use an example of the Z distribution, which we convert this A into what? 0. Now we can use the critical value. Let me take the example of a left tail test. We know that the level of significance is alpha. So we will set that what is Z, so that the area to the left of Z is alpha. This is what we call the critical value. So when we compute our test, when we have our test value, we want to determine if the Z value of this test value, which could be the sample mean, the sample proportion, if the Z value of that test value is in this bad area. That means it's inconsistent with the null hypothesis. So if it is somewhere here, we are going to reject the null hypothesis. I made it. It's not like I made a mistake, but I want to redo it. This is 0. This is the critical value. So this area is alpha. If the test value gets into this area, we will reject the null hypothesis. So if we know this critical value, we may just compare the test value to it. If the test value is less than it, we reject the null hypothesis. If it's for a right tail test, if the test value is bigger than the critical value, we reject the null hypothesis. If it's for a two tail, we will just compare with any of the test value to see if it is in the rejection region. Do we understand what I'm trying to say here? But it's much easier in most cases to determine the area to the left or right of that test value. For example, suppose my test value is here. Let me use letter T. My test value is here. Is it in the rejection region? Are you guys with me? I know you can. Is it in the rejection region? Yes. We can say that because we see how it is before minus ZC, right? But can we also use the area? That's why I removed that, because I put this for all of it. Can we also use this area to the left of T to compare it to the area to the left of Z, which is alpha, and determine whether it is in the rejection region or not? So it is sometimes possible to find the area to the left of T. That is what we call p-value. The probability that Z is less than T. For a right tail test, is the probability that Z is greater than T. For a two tail test, is twice that probability. So we will be using the p-value in this class. Critical value, how do we find the critical value? If alpha equals to 0.05, critical value will be minus 1.645. If it's a right tail test, 1.645. If it's a two tail test, we will say, okay, if alpha equals to 0.05, we divide that alpha by 2. 0.025 on one side, 0.025 on the other side. We have minus 1.96, 1.96. And sometimes that is just what some people use. But as you may be having to deal with many cases, the p-value is easier to get from your calculator and sometimes from Excel. It gives you the p-value, which you just compare to alpha. So we are going to conclude here that the procedure consists of rejection decision. If the p-value is less than or equal to alpha, reject H0. Otherwise, do not reject H0. So remember that when the p-value is small, it shrinks the test value into the rejection region. So it's for p less than alpha that we can say we are sure that this sample is contradicting the statu quo on H0. So in hypothesis testing, what we are going to be doing, and you are learning it at the same time for your exam, which will be the final exam, you will have to state the hypothesis, what is H0, what is H1. Compute the test value, you will put all the information in your calculator, and you should know which one is the test value when it gives you the result. We are going to do some examples today. So, when you reject the null hypothesis, you can now look at the question that was asked to determine is based on this decision you have taken, what can you say about the question? And so, if sigma is, what distribution do we use? If sigma is known, what distribution do you think we should use? Z, right? Use the Z test. R minus mu over sigma divided by square root of n. If sigma is unknown, use what? The T test. T equals to x bar minus mu over s divided by square root of n, degree of freedom, n minus 1. So you will understand these things better as we do a lot of it. I am quickly discussing all the general for section 1 and 2, and then we are going to be looking at examples. And as we move on, you will get used to how to conduct tests. Testing mu when sigma is known. I've already told you about this. Example. If sigma is known, Z equals to x bar minus mu. That's why we will be writing mu equals to. I think mu equals to is the number you put here over sigma divided by square root. Sigma is unknown. T equals to x bar minus mu. Degree of freedom. This degree of freedom is like this if you are using the table at the back of the book. Everybody has calculator. Please make sure you get that calculator. For now, we need it because we want to learn a lot. It is not about learning the mathematics, it's learning the statistics. Calculator is very useful for you. Can somebody read this example? Or everybody read it silently? You like that kind of class like in church? Nobody read. In church, only one person talks most of the time. I'm not laughing at church. I like church. Who like reading? Yes, thank you. Okay. There is a question here. Is the climate really changing? So to study that, it has been determined that the level of sunspot can help us determine if climate is actually changing. So for this area, we knew that the sunspot activity had an average of mu equals to 41. And we are saying that anything above this is an indication of climate change. Is that? Sunspot activity above this level may be linked to gradual climate change. We all see that. So if we are asked the question, do the data indicate that the mean sun activity during the Spanish colonial period was higher than 41? Should this be the null hypothesis or the alternative hypothesis? So what do we think? What is the claim here? Yes. Look at the question. It has the claim. Pardon? Mean sunspot activity during the Spanish colonial period was higher than 41, right? You are going to be doing that for your exam. You are going to identify the claim. Generally look at the question. You will find the claim. So I'm not going to write it literally, but for the exam, I will be asking you to write it in. I want to see it and move your data. So I would have written means sunspot activity during the Spanish colonial period was higher than 41. For your example, you just copy and paste. So we are going to say mu is greater than 41. Is this H0 or H1? Is this claim H0 or H1? H1, right? Mu is greater than 41. Mu is equal to 41. Remember that equal is just right. It doesn't really mean that it's equal. So, what is the sample mean? What is 7? What is the population standard deviation? So, the test value is x bar minus mu over sigma divided by square root, which is 47 minus 41. That's why we are writing mu equals to, because we are going to use it divided by 45 square root 40. Then we are going to have z equals to, we are saving our time because I know you are going to be using it. I'll actually give you an example. So this is the Z value. Now, what was alpha? Anybody remember what alpha was? 0.05. Is this a left or a right index? This is what we use. Is it left or right? Less than left, greater than right. Is it left or right? H0 means that it is, I'm sorry, you cannot even help me. So H0 is mu is less than or equal to 41, right? That is, to be consistent with H0, our Z value should be on this side. You go there is a change. There is something wrong happening. Not actually wrong, maybe it can even be better, but not the way we have been thinking. Do we understand this? Out of normal, out of regular, not normal, out of regular. So, Z alpha is here, and this is alpha. What is this area? So Z alpha is 1.6. You can say 6.4. Is this Z in the rejection area? Is this Z in the rejection area? 1.08, is it after 1.64? Compare. So it's not in the rejection region. Do we get what I mean? For this tail to be 0.05, you did it in your homework at the beginning of chapter 6. This is 1.645. 1.08, should it be before or after this? Is it in the rejection region? It is, yes. What is Z? So that the area to the right of Z is 0.05. Remember, inverse, normal, we will play with that. 0.05, we give you this 1.6. But you don't really need to do that. I want to teach first. This part I'm teaching, I don't really ask you to do it this way. We are going to use the p-value. But what I do is I want you to know that there is another way to do it manually. You understand what I mean by doing manually? I'm doing it manually first. But you can check it, but that's not what I will be asking you to do. It's just like those Z alpha over T that we were doing in confidence interval. I have already given you, how do I know? If this tail is 0.05, it is 90% confidence interval. The middle, 90 for this to be 0.05. And I use that to remember. So it is not in the rejection region. Not in the rejection region. What should be our decision? Should we reject or not reject H0? If it is not in the rejection region, should we reject or not reject H0? We will not reject H0. If this statistic, what we call statistic is what we got from the sample. If this statistic leads to not reject H0, what should we say? Do we have enough evidence to support the claim? This is the claim. Can we support it if we cannot reject based on what this sample gave us? We will say at alpha equals to conclusion. At alpha equals to 0.05. There is not enough evidence to support the claim that, what was that claim? Sunspot activity in the Spanish colonial period has changed. So at that conclusion, you are going to say there is not enough evidence to indicate that the mean sunspot activity during the Spanish colonial period was higher than 41. Write it neatly like that. Most of the time, I will just say claim, please. Exam, you will not be there, it's final. I don't like to reject the claim. To reject the claim, that you just copy and paste. If somebody sees it, even if this student knows what he's talking about. Okay? Ready to go to the calculator? You don't have time to enter this data, but I hope you know how to enter data into your calculator. We are going to use statistics, if you can understand what I mean. You have the choice between data and statistics. We have the statistic, we want to use statistics. You will go to Start. If you were to enter data, you will go to Edit and enter data on L1. But now you go to Test. The first one is Z-test on the calculator. So Z-test. If you have a question, you enter the information. You will ask you for sample mean, sample size, population standard deviation. That's what they start with. Can you all see where those are? If you don't see, let me know. Please, if you don't see something that you need, let me know. Yes. You will start with 80. Mu 0 is 80. You will put 41. Mu equals 41. Yes. Mu 0 is 80. The last one is 81. What is the p-value? Equal to 0.1. So now, to make the decision, we are not going to follow this. This is what I will be asking you on the test. State the hypothesis. You know how to state the hypothesis. What is the test value? Is Z. Yes. Question? Pardon? What are you getting? What is your test value? Or you probably choose 2 tail instead of 1. You will just wait to calculate. So you see your mu is different. These are the little things you should be watching. Okay? So just go back to Start. Yes. Just go back and choose greater. Okay? So if you have see something wrong, just say it and we will clear it up. So what is Z? 1.08. I will ask you what is the test value. First question, identify the claim. Second question, what is the test value? Third question, what is the p-value? Fourth question, what is the decision? Decision, P is greater than alpha. So reject, do not reject. Conclusion, based on this decision, you are going to look at where the claim is, because sometimes claim is 80, sometimes it is 81. We are going to be discussing that as we do more examples. That is just the statement of the hypothesis. But we are always testing H0. Very important. No, H1 doesn't go anywhere. Don't use H1 anywhere, so far as it is in this class. H0, we are using it because it is the statute code, and we are going to be testing it all the time. But we are interested on a claim. That claim could be H0 or H1. We are going to come back to it. Any other question? I want us to do 2 examples. But if you have a question, ask. So, decision do not reject H0 is what we did. The conclusion will follow. So here you see how to use your calculator. Now, another example. I will read this one. The drug 6-MP, the drug 6-MP is used to treat leukemia. The following data represent the remission times for a random sample of 21 patients using 6-MP. The sample mean is 17.1 with sample standard deviation 10. Let X be a random variable representing the remission for all patients using this drug. Assume the distribution is mouse shape and symmetric. We always want that. I am not too much paying attention to that. A previously used drug treatment had a mean remission time of 12.5 weeks. Do the data indicate that the mean remission time using the drug 6-MP is different from 12.5? What is the claim here? What is the claim? How do we consider the claim? Look at the question. Yes. The mean remission time is, for your exam, you will copy and paste. Remain the same. If you say remain the same, it is correct, but we want to say is equal to 12.5 weeks. So should it be H0 or H1? H0, mu equals to 12.5. You can put here claim so that you don't forget. And here mu is different from 12.5. Now we will use calculator. If you like to use the data, because we have some minutes. Or should we use data or should we use statistic? Okay, somebody says statistics, so let's use statistics. Which test are we using? Do we have sigma? We don't have sigma. Which test are we using? T test. We are going to be singing all the time. If no sigma, T, which is 2. So pay attention to that. Here I would have taught you how to read the physical value more than 1.645. For the T distribution, you have to read their own table. It's a little bit. You can see it on the PowerPoint. If you have a question using your calculator, right? Are you done? No. I'm doing something else. Practice using your calculator, then you will love it. If you don't use it some days, you will hate it because it might not help you. So, start, test, 2 for T test, and you will enter the sample mean, sample standard deviation, sample size, 21, and then you will decide the test is 2-tail, it's different. If you choose 1, you will see that if you choose 1 instead of 2-tail, your p-value will be half. If you choose 2-tail when it is 1-tail, your p-value will be double. Somebody's done? Anyone? So what is the test value? 2 point. this is what I will be grading on the exam. I want you to pay attention to these details. If you put Z here instead of T, you will lose points. Because this is what tells me that you know what distribution we are using. Are we getting this? Pay attention to that. I will be reminding you all the time. So it's not because you are using your calculator that you are not working. Your brain must remember why you are using what you are using. So what is the p-value? 0.048. Do you remember what was alpha here? 0.01. So this is P. What should be our decision? Alpha equals to 0.01. Can we compare P to alpha? Is P less than or greater than alpha? P is greater than alpha. So do not reject itself. Conclusion. And alpha equals to 0.01. Sometimes in your book they don't write this, but I like that you write this. Because if you change alpha, you are not going to make the same decision. Look, if we had 0.05 here, are we going to make the same decision? If it was 0.05, I'm sorry, if alpha was 0.05, are we going to have the same situation? Do you see what I'm saying? If alpha was 0.05, did you say P is greater than alpha? No, right? This is 0.04, this is 0.05. So this decision is based on alpha. At alpha equal to 0.01, there is not enough evidence. Pay attention to what I'm writing here. To reject the claim that the data indicate that the mean remission time using the drug is different from 12.5. Oh, it was different. So this is the claim actually. It was different, right? So the claim is different. I didn't pay this not much for now. So just pay attention. Nothing is changing much. It's here that that information is important. There's not enough evidence to support the claim. Now is to support the claim. This mistake I've made here will help you know what you say here is reflected back here. There is not enough evidence to support the claim that the mean remission time is different from 12.5. If I do homework, we are going to come back to it, most of the aspect of those little details about. So your PowerPoints also have testing using critical value, which I have discussed already. Critical value is when you find the 1.645 rather than the p-value. But we are focusing on p-value for our own objective. We are focusing on p-value. So you can do homework for 8.1, 8, and 8.2. We are good for those in Zoom.